So in this video, we're talking about secants and how they relate to circles. Secants are lines that intersect a circle at 2 points. So we have three different relationships, one little typo there. The measure of an angle formed by two lines that intersect a circle is half the sum of the measures of the intercepted arcs. All right, so let's actually tackle problems related to that first. I'll try to color code it a little bit. I'll go green for this one. All right, so, well, actually, I'll go red because that's how I made the little annotation there. So, intersect inside a circle. So let's hop on down to number 17. All that's telling us is that if I want to find the value of x, I just want to find the average of the two angles that make up the intersection of the circle with that given angle. And so you're dealing with vertical angles being congruent. So I have another x degrees on this side. So I have two angles that correspond, or two intercepted arcs of the circle that correspond with angle x. So all I'm going to do here is find the average of the two. And so from there, we determine that x has to be 87 degrees. All right, so that's actually the most straightforward one. The second one, which I will now go green for, same idea, but if the intersection occurs, and we're dealing with angles for the first two, intersection occurs outside of the circle, it's going to be half the difference of the measures of the intercepted arcs. All right, so here we're looking at 70 degrees is going to be equal to 1/2 the difference between W degrees and 110 degrees. So if I want to get the W alone, I'd have to multiply both sides by 2. So 140 is equal to W degrees minus 110 degrees, which means that 250 degrees would be equal to W degrees, which should make sense because if you know that one arc of the circle is 110 degrees and there's two arcs, there's 360 degrees in a circle, so the other one would have to be 250. All right. Another one that follows this general idea is number 15. Here we're looking for that exterior angle. X degrees would be equal to 1/2 the difference between 90 degrees and 70 degrees. Oh, 90 degrees and 70 degrees, geez. 20 degrees, which is 1/2 of 70. That's where I had the 70 in my mind, which is 35 degrees. All right. The remaining ones are related to the weird concept. For a given point and a circle, the product of the lengths of the two segments, blue for those keeping score at home, the product of the lengths of the two segments from the point to the circle is constant along any line through the point in the circle. All right. So what that's telling me is that if I'm going from the point to the circle along a secant, there's a couple of ways I could do that. I can go directly to that first intersection, but I could also go to the second intersection. All right, I'm going to have to go two colors here. So I'm going to have the red and the blue. All right. And the same will be true on this side. I'll make it blue just for consistency. All right. So what they're telling us here is that indirectly that the overall length is going to be 34, and in this case the overall length is going to be 16 plus x. So if I take those two lengths, the 14 and the 34, multiply them, and then I also take in the same order the 16 and the 16 plus x, that would be a correct relationship that it would allow me to solve for the value of x. All right, so 14 times 34 is 476. I'm going to divide that by 16. So little decimal value, 29.75. Subtract off the 16, and I get x equal to 13.75. All right, so easily the most complicated of the two. All right. Now, again, for a given point and a circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point of the circle. All right, so here's the point. This one's a little easier because, let me use my line draw tool. I have components here, x and 2 that fall along the same line. And then 8 and 2.5 also falling along the same line. So in each case, it's point of intersection to the circumference of the circle, but here we don't have to worry about any crazy algebra. All right, so 8 times 2.5. All right, I'm just going to divide out the 4 immediately. Well, you just do it all in one shot, I guess. So x would be equal to, what was it, 10? 8 times 2.5, yeah, divided by 2 is going to give you a 10. All right, so that one's definitely not bad. 16 is definitely the weirdest looking one, but it's actually not terrible either. So again, we have a distance to the circle here, and we have another distance to the circle here. So 2 times 9. Now we have a distance to the circle here, but we also have, since the tangency is really just kind of 2 points that have merged together, we would also have another measure that's going to the same point. All right, that's the strangest, easily the strangest of the different relationships. All right, so y and y. So we're looking at 18 is equal to y squared. And so y would be equal to the square root of 18, which can be broken down into the square root of 9 and the square root of 2, making y equal to 3 times the square root of 2. All right, and so those are the different cases involving the secant, and that'll do it for our circle lesson. So online there will be a quizzes related to this topic, just a 10-question quizzes, nothing too crazy. And so you'll have a week to complete that. So no, you won't have to submit any note-taking or anything like that. Just work on that quizzes. And then next week we'll wrap up the course because we're pretty much there with